Hi guys, this is our lesson for our snow days. So we missed Monday, not doing anything to make that up, since we also are now missing Wednesday. I'm making this lesson for you to do at home and do the Delta Math at home. If we also miss Friday, I won't do anything else. But if we miss another one next week, so if we miss next Tuesday, I'll do this again. I'll make another video just so we don't miss too many days and we're still on track to be ready for the AP exam. So we've done arc length before. We did this with rectangular functions. So just to review, it was integral from a to b, so your starting to ending point, big old square root, and I always put 1 plus blank squared, and in the blank you put the derivative of your function. So we did that before. You just kind of memorize the formula, plug it in. Parametric is almost the exact same thing. So it's going to be integral from your starting point to your ending point. Instead of dx, it's going to be dt, because you now have, an x variable in terms of your parameter t and a y variable in terms of your parameter t. And so you're just going to do both of them. And it relates to this exactly. F prime of x is, your derivative of y, if you want to think of it that way. And your derivative of x just is 1 in rectangular. So it is your derivative of x. It's just that would just be 1 in that case. So they're all, they are basically the exact same thing. So we're just going to practice that a few times, and that's kind of it. That's why I figured this would be a good lesson to do from home, because there's not really much to it, and you've kind of already done it. So we're going to go from -1 to 3, big square root, and leave it blank. So you're going to have blank squared plus blank squared. The dogs are downstairs. They will not stop barking. You know what? I'm going to go get them and introduce them to you. Hold on one second. Hi, actually showing my face on a video for once. These are my dogs. This is the culprit that will not be quiet. And this is the little quiet one. All right, you guys need to be quiet because mommy's working, okay? If I put you back downstairs, you can be quiet. All right. All right, so back to this problem. So in this first little blank, we're going to put derivative for x, which is just going to be 3. Derivative for y is just going to be -2. I'm starting out with an easy one. So if we go ahead and square both of those things, this would be 9 plus 4, which would be 13. And we realize that looks funny because it's a square root, but it is just a number. Square root of 13 would just be a number. So pretend it's like 4 or something. Pretend it's like a really simple number. When you do the antiderivative, it's going to be that t, just as though if there was a 4 there, the antiderivative would be 4t, and then such that -1 to 3. And so we're going to do upper minus lower. So 3 square root of 13, and then this would be -1 square root of 13. Negatives cancel, you get 4 square root of 13. And just to remind you what it is that you're actually finding, if we were to graph this, and you've practiced graphing parametric equations, this is the distance from t being -1 to 3. So those ones that we practiced graphing and drew them on paper and we put little arrows for the orientation? It's the distance of that curve, which is cool that you can find that even if it's not a straight line. This one would be a straight line because I made it real simple. All right, let's try it again. So this is going to be integral from 1 to 4, big square root, and we're going to leave our 2 blanks in here, blank squared plus blank squared. And what goes in there is your derivatives. So this one's going to be 12t. This one's going to be 6t squared. Next step, leaving this big square root in there. That is going to be 144t squared. Plus, and then this would be 36t to the 4th. Now we are going to keep going because we can do this one by hand. What we're going to do is factor out the greatest common factor from these, which is going to be 36t squared. I know 36 goes into 144. I'm not remembering that right now. I think it's times 4. Let me just make sure off to the side. What would that be? 24? Yeah. I had to think about it for a second. All right, so that's going to leave us with 4 plus t squared. So if we factor that out, greatest common factor, this is what we are going to be left with. And then it is going to be a u substitution. So actually, I'm going to erase my little margin problem here so I can put the u substitution there. So u is going to be this part that it, oh, actually, I have one more step before I can do the u substitution. I'm going to have to actually square root this part. So if we square root, because right now the whole thing is under the square root, and I need to get this part out of there. So if you square root 36, that's going to be 6. If you square root t squared, that's just going to be t. And actually, I'm going to write this the other way around just because that's my preference, right? So we're going to let u equal the stuff that's inside the square root. Again, the point of a u substitution is you're doing kind of a chain rule backwards. You want for this to be the guts of the problem, the inside stuff. Also, you know you need u substitution if you can't just write the answer. If you can't just do this antiderivative in your head, like the way we did antiderivative of square root of 13 is square root of 13t. If you can't just do the answer, then you need to use one of your other methods. So this derivative would be 2t dt, although I have a 6t there. So I'm going to multiply by 3 so that this now matches the 6t dt. In its place, I'm going to put 3 out front, du at the end. Hold off on the boundaries because we're going to have to adjust those. What's left is square root of u. I'm going to write it as u to the 1/2. That'll make it easier to do our antiderivative. And then it's real simple to change the boundaries. You just have to remember to do it. You're going to plug 1 in for t. That's going to give you 5. And we're going to plug 4 in for t. That's going to give us 20. Make sure I did that right in my head. Yep. All right, so our antiderivative, you're going to add 1 to the power. That's going to make it 3/2. Out front, you would put 2/3. That 3 coefficient is still there, which is actually really convenient because those are going to cancel, such that 5 to 20, and we're going to do upper boundary minus lower boundary. So if you plug in 20, you're going to get 2 and then 20 to the 3/2. And then if you plug in 5, same exact thing, but with a 5 in it. And again, if you were to put this into a calculator, it's going to give you a number. It would be some kind of weird decimal, but it is the length or distance of the parametric curve from when t is 1 to t is 4. So again, if you were to graph these and look at it, it is the length of that curve. It's a distance is what you're finding. These ones in the back, we're just going to set up. Oftentimes with multiple choice, that's how it'll be. It'll be which one sets this up correctly. But they do some simplifying, so we will have to consider that. This is really washed out. Oh, that's better. All right, so great big square root. Actually, I'm going to need a lot of room for this one. And we're going to go from 0 to pi. And I'm going to leave my blanks in here. Give myself some more room. Sorry, the projector is right above my hand, so it's hard for me to squish my hand in there without bumping it. All right, so we're going to do derivative of x. It's a chain rule. The outside function is that squared. We're going to bring the 2 down. It's going to drop to a 1. You don't have to write the 1. I'm just showing you because if it disappears, that confuses people. So bring the 2 down, drops to a 1, and then we chain on the derivative of cosine, which is negative sine. I just barely made that fit. All right, so same thing here. We're going to bring the 5 down. It's going to drop to a 4, and we're going to chain on the derivative of the inside function, which is sine. So derivative of sine is cosine. Now, your multiple choice answers aren't going to look like that. We're going to have to clean it up just a little bit. So first of all, this term would be negative, but when we square it, it's going to turn positive. So I'm not going to worry about writing that. A negative times a negative will turn positive. I'm just going to square everything else in here. So 2 squared is 4. I'm betting in multiple choice, they will probably put the sine before the cosine. So I'm going to put sine squared of t, cosine squared of t, plus, and then we're going to do the same thing over here. So 5 squared is 25. When you do a power to a power, you multiply. So that's going to be sine to the 8th t cosine squared t. That's a lot to sift through. So, and when you do multiple choice, they're all probably going to look pretty similar. So you got to be really careful. All right, last one. Again, we're going to just set this one up kind of like the one we just did. It'll probably involve some simplifying, but we're not going to work it out the whole way. So this will be from 1 to 7, gigantic square root. Leave your blanks. Derivative of x is going to be 6t squared plus 1. Derivative of y is going to be 8t. So when you go to work this out, and I would probably just do it as a margin problem, and if you can do this in your head, that's cool. If not, just write it off to the side. When you do 6t squared plus 1 squared, it means this. You have to distribute everything to each other, right? You have that twice. It's a twin. So when we multiply the first terms, it's going to be 36t to the fourth. The outsides give you 6t squared. The insides give you 6t squared. So together is 12t squared. And then 1 times 1 is 1. Hey, Miss Cole, is there a shortcut? No. If there is, I'm going to tell you, because I am going to do every problem in the easiest way possible. If there was a shortcut, I would let you know what it is. If you can do that in your head without writing it out, that's kind of the only shortcut that there is. All right, and then 8t squared, we're going to square the 8 and square the t. And then last thing, we're going to just combine these like terms. And then this will be our final answer. So 36t to the fourth. What is that going to be? 76 t squared plus 1 dt. So your job is to check your understanding 8.2 if you didn't already. I think most people got most of it done in class. Some of you had been out that day at the AP fair, which I super appreciate. So if that was you, just make sure you do 8.2. And then 8.3 goes with what I just taught you. And just send me a Schoology message if you have any questions. Again, if we're not back the rest of this week, we're going to just let the rest of this week slide. If we miss a day next week, I will do another video.